Hello guys, so we are back again in the second lecture of limits, and in this session we are going to do some more questions on 0 by 0 form. Till now we have done two questions and now we are going to do some more questions. So the next question which we are going to do is as follow. The question is limit x tends to 0 x cos x minus log 1 plus x upon x square. Process is very simple, you just need to follow the steps. Write it L, limit x tends to 0 x cos x minus log 1 plus x upon x square. Substitute the values. What you're getting is 0 minus 0 upon 0, which is 0 by 0, which is indeterminate form. You have to mention in the next statement it is an indeterminate form. I am using a representation. Okay, now apply L'Hopital's rule. What you will get, differentiate this. Differentiate the denominator, substitute the values. Again we are getting indeterminate form. Apply L'Hopital rule again. What you get, substitute the values. So we are getting 1 by 2, which is not an indeterminate form, which is a fixed value. So our answer will be what? Our answer will be, this is the final statement in which you will write the answer as x equals to 0 x cos x minus log 1 plus x upon x square should be equal to 1 by 2. So this is our answer. Hope you have understand each and every step. Now let's move on to the next question. The next question is as follow. Limit x tends to 0 sin x minus tan inverse x upon x square log 1 plus x. What we have to do, write this thing, limit x tending to 0 L sin x minus tan inverse x. This is very crucial statement you have to write, and then substitute the values and check the nature of the limit, no matter what the problem is. Indeterminate form. Now before, just write this line, before applying L'Hopital's rule, simplify the denominator. But the trap part here is, I will tell you what children do. Okay, so multiply and divide by x in the denominator. What you get, now I can do one thing. You have to write this step, x tends to 0 sin x minus tan inverse x upon x cube, and after this you have to write this step. Means you have just separated the limits. here you can apply that formula. Log 1 plus x upon x is nothing but 1. The moment you apply that, you will be left with limit x tends to 0. You have to mention it here, okay. Then you will be left with sin x minus tan inverse x. Now never break the denominator. As I have mentioned, you will get a indeterminate form, okay, and your whole answer will be wrong. Always go with the L'Hopital's rule, because here you are having tan inverse x upon x. Apply. What you will get, I will solve it here. If I simplify, I have cos x 1 plus x square 3x square. If I substitute the values 1 1 0 0 by 0, we have indeterminate form. Apply L'Hopital's rule. Again you will get L equals to limit x tending to 0 minus sin x plus 1 upon 1 plus x square the whole square into 2x upon 6x. Now just think, if I distribute my x, this sin x upon x and this x will cancel out, 2 upon 1 plus x square, the whole square will be left, which will be a finite number for sure. So I will do what? I will distribute the things and take 1 by 6 outside. The moment I distribute, I will be left with, you have to mention each and every step. And here also limit x tend to 0 will be there. The moment you break, limit will turn out and you have to substitute. That is the problem. You have to think always before breaking the things, okay, in L'Hopital. This will become 1, and here this will 2 xx will nullify, 2 will be there, and this when I substitute 0, I will have only 2. So my final answer will be 1 by 6. So this is our answer, okay. And the final step, you will do what? You will write this n equal to 1 by 6, okay. Then you will get complete marks. Now let's move on to the next question. The next question is as follow. We are going to solve this question, but before, okay, let me get the pages. The question is limit x tends to y, x power y minus y power x upon x power x minus y power y. Apply. No, okay, write this line. Okay, x tends to y. Okay, just keep in mind what you have just written. Y power x upon x power x minus y power y. The moment you substitute here x y, it will be y power y minus y power y upon y power y minus y power y, giving you 0 by 0, which is a indeterminate form. Here remember, here x, okay, here remember x is a variable and y is constant. Okay, many children have confusion because we are x is tending to y. Okay, y is a constant value. Apply L'Hopital's rule, because we cannot do any further modification in this. The moment I apply x tending to y, this will be what? Y power x log y, right? So what we are left with here, x power x into 1 plus log x plus 0. Now many children have a doubt how you wrote x power x into 1 plus log x. Always keep in mind you have to just memorize this thing. Okay, I will tell you once only. If x power x, okay, is a function f of x and I want to find its differential, I will call it some v. I will differentiate both of them with respect to a dv by dx equals to it will be what? Okay, first thing I will do one thing, take log on both sides. The moment I take log, I will be left with log v equals to log x power x, which will be x log x. Here if I differentiate, I will be dv by dx with respect to x. Here I will be x upon x plus log x, which you can clearly see 1 plus log x. I want dv by dx, so I will shift the v here, so it will be v into 1 plus log x. But my v was x power x, so x power x into 1 plus log x is the differential of this thing, so which you have to need to memorize, and that I have substituted here. Many children don't understand that thing only, and they, okay, which indirectly means that the class 12 things are not clear. So what I will do after this, I will substitute x is equals to y, which will give me y power y minus 1, y power y log y upon y power y into 1 plus log y. Here you can clearly see we can take y power y common, give me 1 plus log y left as it is upon y power y 1 plus log y. Finally we are left with 1 minus log y. Since y is constant, so this is a constant value, so our indeterminate form is now not present, so this is our answer. So what you have to do, you have to write this thing and equal to this value, and you will get the complete marks. Now let's go on to the next question. The next question is this. This question is as follow: limit x tends to 0 tan x minus sin x upon sin cube x. Okay, so what you can do is, before, okay, first do this. First step is very simple. What you have to do, check the form. The moment you substitute the value, you will be 0 minus 0 upon 0, giving you 0 by 0, which is an indeterminate form. Now, before, again, I can simplify my denominator by multiplying and dividing the denominator by x cube, which is applying sin x by x, where x tending to 0, which is nothing but equal to 1. So before, simplify, what we get, in the next step, you cannot substitute directly here 1, your marks will be cancelled. If you substitute directly, you have to show them this step. Now after this step you can simplify, giving you finally this will be equal to 1. You have to mention the formula here which you have used, so you are finally left with tan x minus sin x upon x cube. Should I distribute the x cube? No, it will just create an indeterminate form again, because sin x by x and sin tan x by x will become 1. Yeah, that is right. But 1 upon x square, it will be nothing but infinity minus infinity. Okay, which is a more troublesome thing. So don't go for that. Now go do the similar thing which you do. Apply L'Hopital, sorry. Many children say L'Hopital's rule. That's why I frequently get forward. Okay, apply L'Hopital's rule. We get substitute the value, which is again indeterminate form. We will solve it further again. What we will do, the moment I apply this, what I am getting, we have to differentiate this thing. Okay, when cos x will be differentiated, okay, we will get plus sin x. Okay, we'll get plus sin x upon what we are left with here is 6x. Now what we are going to do is we are going to distribute the x, since I know here tan x and sin x by x will. So here what you have to do, you have to break the things. Sec square x tan x by x sin x by x. Here 1 by 6 will be there, keep it separately. What you're getting, final answer is 1 by 6 to sec square x. Here still limit x tends to 0 here. Okay, I have limit x tends to 0, but here it is constant, doesn't matter. Okay, you can also avoid writing this step, doesn't matter, but you have to write this limit. After this, when you substitute the values, finally you will be left with 2 plus 1, giving you 3 by 6, which is nothing but 1 by 2, which is our answer. Okay, so hope you have understand this problem, and after this step you have to write this thing equal to this, you will get the complete mark. Okay, sorry for the here some silly mistakes. Okay, we did. Okay, hope you have understand. Now let's move on to the next problems, which is this one. Problem says as follow: limit x power x minus x upon x minus 1 minus log x, where x tends to 1. What we should do, we should directly do what we should focus on. Here first write the step which we write. Okay, the moment I write, after this what we can do, after this substitute the values, you will get zero by 0, which is an indeterminate form. After this apply. What you can get is, since it is x power x and I have told you to memorize it, it is nothing but 1 plus log x. This will be 1 minus 1 upon x. Substitute the values, what you get, 0 by 0. Again differentiate it, see what you are getting. If I differentiate it again, what I'm getting, okay, this will become 0, this will be 1 by x, 1 plus log x, this will be as it is, it will be x power x into 1 plus log x. I have told you to memorize this thing, upon 1 upon x square. If I substitute 1, what I am getting, 1 plus 0, this whole thing into 0, okay, so complete 0, okay, complete 0 upon 1, this will be, sorry, I did a mistake, 1 plus 0, after this it will be 1 into 1 plus 0, which will give me 1 plus 1 upon 1 plus 1 upon 1, which is nothing but, okay, wait, this will be multiplied with this and there will be no 1, it will be only 2, so 2 is the answer. Okay, so this was our answer. Hope you have understand each and every step. It was just applying L'Hospital, observing whether the denominator can be simplified or not, observing whether after breaking the denominator whether I will get an indeterminate form again or not. So these things you should keep in mind, okay, and be aware before solving any problems. This is the last problem which we are going to do at the first step. After this, what you will do, substitute the values, 0 by 0, indeterminate form. What we are going to do, okay, can we simplify the denominator? No, it is log 1 minus x. So what we are going to do, apply rule. What we get, so we are getting this thing. Now substitute the values and check whether we are getting right thing or not. Okay, whether we are getting some constant value or not. Here log 1 minus x, 1 upon it will be minus 1 also, so we will be left with, okay, it will be minus 1 also. Now if I substitute the values, what I am getting is 0, 1, 0 minus 1 upon 0, 0, 0, which is nothing but 0 by 0, indeterminate form again. Apply L'Hospital rule. What we get, what we are getting after applying, what we are getting, minus keep inside, okay, keep outside. If we simplify, okay, or we substitute the values, if we can get the direct values, then it will be fine. This and this will cancel out. we are left with 1 here, minus 2 upon 2, here 0 1, minus 1 upon 0 1, and here 0 is there, and this will be minus 1. So we are getting minus 1. We are getting something like minus 1, which is okay. We are getting something 2 minus 1 minus 1, so which is a constant value, so we don't need to solve it further, and we will stop here. So this is our answer. You have to write this and tell it is equal to minus 1. So we have done with one part of L limits, which is 0 by 0 form using L'Hospitals. See you in the next session. Till then, take care. Bye. Keep studying, and if you like our content, please subscribe the channel and share it with your friends, okay, who are in engineering, okay, and are stuck in this chapter. Thank you.